Welcome back to the deep dive. Today we're going into a world of incredible specificity.
We really are.
Our source material is a technical blog post from the self-described old software plumber named Ang. And we are taking a laser focus on one of the smallest, yet maybe one of the most disruptive symbols in the functional programming language Haskell.
A $sign.
The $sign operator.
It's so true. For anyone out there who programs, you know that sometimes the most powerful changes come from the tiniest keystrokes.
Right.
Our mission today is to really demystify this one character. It looks like it's purely stylistic shorthand, a way to clean up some visual clutter.
That's what I thought at first.
But we're going to show you how the $sign fundamentally alters how Haskell code gets evaluated. It transforms what seems like a cosmetic choice into a really critical mechanism for controlling execution flow.
So in a language that's built on mathematical rigor and this idea of elegant composition, understanding a symbol this small, it feels like a shortcut to understanding the entire programming style.
It is. We're moving beyond just syntax cleanup to understand its role as a function application operator, something that actively changes the order of operations.
In a language as particular as Haskell, I guess it makes sense that the smallest symbols carry the most technical weight.
Exactly. You have to go past the surface appearance and see that the operator is really the key to managing function composition in an efficient way.
Okay, let's unpack this. Let's start with the immediate practical motivation that our source author, Hang, brings up first.
Reducing visual clutter.
Right. This is the entry point for most developers when they're learning the symbol, I'd imagine.
It is, yeah. I mean, anyone who's looked at complex functional code or even some of those command line parser definitions in Haskell has seen the nesting nightmare.
Oh, yeah.
You just end up with parentheses within parentheses within parentheses, and they're all necessary to force the evaluation order you want just because of how functions group by default.
So let's look at the specific example from the source. It relates to defining a main executable function. The version without the $sign looks like this. Main, xparser, info, empty helper, ADAM.
You see it right there.
You could immediately see those two levels of nesting. It's just to make sure xparser applies to the whole info expression after it's been calculated.
Now compare that to the version where the developer uses the $sign. Main, xparser, info, empty helper, EDM.
The visual difference is it's immediate. It's pretty profound. The symbol just acts as a stand-in for that outermost set of parentheses.
Right. It simplifies the whole expression, and you don't need to wrap that entire argument block.
And for a lot of developers, this makes the code base simpler. Complex statements start to read more like a sequential pipeline. It just flows left to right.
And that's exactly why it's become such a signature stylistic choice in the Haskell community. It gets rid of what some developers call the leaning tower of parentheses problem. It just lets the expression breathe.
But, and this is where we get that little bit of friction, which I always find useful.
Okay.
Our source author, Ang,
The old software glummer.
yeah, who writes about everything from code to gardening, he actually offers a counter perspective. Ang says they personally find explicit parentheses to be more comprehensive and easier to track.
And that's fascinating, isn't it? Because it reveals this core tension in programming that you see in every language.
That's it, yeah.
It's that balance between mechanical efficiency on one hand and cognitive readability on the other.
I see.
The Haskell community really prizes conciseness, but Ang, who clearly values maintainability and robustness, a plumber who wants to see the pipe joints clearly,
Right.
they prefer the explicit visual cues of the parentheses.
So we had this symbol that's adopted mainly for style, but even the expert source we're using finds some fault with that stylistic benefit.
Yeah.
It's easy to just dismiss the $sign as developer preference. But the source makes it really clear that this preference emerges from a deep technical necessity that's hidden in Haskell's core rules.
And this is where it gets really interesting. This is where the $sign moves from being just decoration to structural necessity.
All about function application precedence. Aren't they?
Absolutely. The technical core of the $sign is completely tied to function application precedence. If you don't get that, you only understand half the story.
Okay, so let's go back to basics for just a moment. Remind us how standard function application works in Haskell, because that's the thing the $sign is designed to override.
Okay, so standard function application in Haskell is just a space separating the function and its argument. So think of a simple expression like FGX.
Okay.
Crucially, that simple space has the tightest binding, the highest possible precedence in the entire language.
By precedence, sounds good, sounds efficient. But what's the actual mechanical implication for the evaluation order when you start combining functions?
Well, because it has the highest precedence, it enforces grouping from left to right. So the compiler looks at fgx and it immediately sees it as fgx. It tries to apply g to f first, and then apply the result of that to x. And that is almost never what you actually want when you're composing functions.
So if I have three functions, and I want my data x to go through g, and then the result of that to go through f, that kind of standard right-to-left functional flow, the high precedence is actually fighting me.
Exactly. You are forced to manually insert parentheses just to force that right-to-left evaluation, fgx.
And if you have 3 or 4 nested functions,
Then you're looking at several sets of nested parentheses, all just to override the default left-to-right grouping mechanism. That's the headache that high precedence creates when what you really want is compositional elegance.
so if that normal function application has the tightest binding, how does the $sign solve this problem structurally?
The symbol is defined in Haskell as the function application operator, and its core defining feature is that it has the loosest binding.
The lowest possible precedence.
The lowest, so it's a right associative override.
So when you use it, you're effectively telling the compiler, stop. Don't apply the function on the left until the entire expression on the right is fully calculated.
Precisely. The $sign acts as this impermeable barrier, or a low precedence wall. When the compiler sees f1gx, the $sign forces the interpreter to evaluate the whole expression on the right, which could be dozens of chained operations first.
And once that final value is calculated,
Then it is passed to the function on the left, to f.
this dramatically cleans up the code then. Because the $sign is taking over the structural job that parentheses used to do, but it makes the data flow conceptually clearer.
It's the difference between writing instructions for a computer and writing instructions for a human reader.
Yeah.
The source gives a brilliant, simple comparison to illustrate this. Think about a nested operation, like formatting a math result for printing. If you use explicit parentheses, it looks like this. Put strlnn, show 1 plus 1.
2 sets of parentheses right there.
Yep. And when we introduce the $sign, the technical evaluation order is forced correctly right to left, and the syntax becomes this straightforward, sequential flow. Put strln $show $1 plus 1 let.
Look at that. That second version reads almost like a sequence of instructions.
It does.
Take the value, show it as a string, and then print that string.
And the $sign handles all the intermediate grouping. It allows you to focus on the logical composition, not the manual precedence rules.
Okay, so to summarize the core technical takeaway here, the $sign isn't just a stylistic cleaner to avoid nesting. It is a structural mechanism. It overrides Haskell's default highest precedence left-to-right function application rule.
Right.
And that lets developers get that natural right-to-left flow of data that you need for elegant functional composition without being burdened by all those manually inserted parentheses.
It's the tool that lets the Haskell programmer switch from thinking about precedence to thinking purely about composition.
That makes a huge difference.
And that ability to abstract away the mechanical concerns, that's a huge win for efficiency and for minimizing errors.
Which brings us to the third, and I think most advanced, role of the $sign. Because Lee's is an operator, it's easy to think of it as, special syntax that's just baked into the language.
Yeah, like a keyword.
Right. But Eng's source makes a crucial point. The A's is actually a regular first-class function, just like plus or a.
This is the aha moment. This is what unlocks the deeper power of the symbol. If it's a regular function, you can treat it like any other function.
You can pass it around, you can name it.
And most importantly, you can partially apply it.
Partial application. The ability to fix one argument of a function and leave the others open. That's a cornerstone of functional programming.
It is.
So since is a function, what does it look like when we partially apply it?
Okay, so the definition of the $sign function, as simplified, is that it takes a function and a value, and it returns the result of applying the value to that function. So if we partially apply it, let's say by writing $5, we've just created a new function, we've fixed the value, which is 5, and now this new function is waiting for a function as its input.
So the resulting function, $5, is essentially saying, whatever function you give me next, I will apply the argument 5 to it.
Exactly.
Wow, that opens up some tremendous possibilities for concise list manipulation.
It does. And the source provides a fantastic example using the map function. Map is often used in functional languages to apply a single transformation to every item in a list.
Right.
But here, we're doing the inverse. We are applying a single argument across a list of transformations.
Okay, let's walk through the GHCI interpreter example slowly for everyone listening. The input is Chi-Chi map, $5 plus 1, 2.
All right, let's break that down. We have a list of functions, plus 1, 2, 3. These are three simple separate functions.
Add 1, multiply by 2, and raise to the power of 3.
Correct. And we're using the map function to iterate over that list. The function we are mapping onto the list is our partially applied $sign, $5.
This is the elegant part.
It really is. The map function takes the first function from the list,
Right.
plus 1, and it passes it to $5. So the structure, $5 plus 1, resolves instantly to 5 plus 1.
Okay, and then map takes the second function, 2, passes that to $5, and that structure resolves to 5, 2, and it just repeats for the third one.
Exactly. So the overall output that GHCI returns is the list of those three results, 6, 10, 125.
6, 10, 125.
The key thing here is that the $sign, acting as a first-class, partially applied function, let us define a single input that was simultaneously piped through a whole collection of completely different processing functions.
That level of conciseness and compositional power really demonstrates why the $sign is so central to modern Haskell style. It's not just saving you parentheses. It's enabling these high-order functional programming techniques in a clean, readable way.
And just to tie off a little detail Ang mentioned in the source about using the GHCI interpreter, they mentioned the it variable. That's just a nice little feature for interactive exploration. Whenever you evaluate an expression in GHCI, it automatically binds the result to that special it variable. So you can reference it quickly in the next line if you want to keep working with it.
So what does this all mean for you, the learner? We started with a symbol that really just seemed like a style shortcut, and we realized it has these two incredibly dense layers of technical meaning. The aesthetic role, getting rid of parenthesis clutter, that's a visible benefit. But the essential technical role, controlling function evaluation order via lowest precedence, that's what transforms the language.
It turns confusing nested logic into clean, readable composition flow.
So if you are reading any complex Haskell code, understanding the mechanical weight of the $sign it sounds like it's non-negotiable.
It is. It's the visual marker that tells you everything to my right is one unit, and the result of that unit will then apply to the function on my left. It's the architectural linchpin of function chaining.
And finally, let's just go back to our source, Ang, the old software plumber.
Yeah.
Ang is clearly someone who digs deeply into the details of any system they encounter, whether that's compiling code in Haskell or Elixir, researching Python and AI, or tracking the detailed requirements of successful gardening and fish keeping.
The sheer breadth of their rigorous documentation is just astounding. They seem obsessed with finding the optimal structure and flow in, well, every domain.
Which raises an important question for you to think about based on Ang's philosophy. If even the simplest operators in a highly technical system like Haskell require this level of deep analysis and debate.
The philosophical choice between explicit parentheses versus the $sign's lowest precedence.
Exactly. Then how much untapped complexity and personal choice is hidden in the tools and systems you rely on every single day?
Think about your own field, whatever that might be. Every system has its own small operator, doesn't it? A tiny overlooked detail or convention that, when you finally understand it, unlocks massive improvements in efficiency and structural clarity.
You just have to be willing to look past the style and dig into the mechanical definition.
That's it.
Thank you for joining us for this deep dive into Haskell's $sign secret.